Hello everyone. Good morning. Hello everyone. Good morning. How are you today? Can you able to see my screen as well as can you hear me? Yeah, very good morning, Ayushi. Gauri Lakshmi. Very good morning. So today we are going to talk about our next topic, that is alcohol, phenol and ether. Okay, so this is the last topic of organic chemistry. So far we have covered all the topics of organic chemistry. Okay, and if you have certain doubts about certain topics, you can give me the topic names and we are going to talk about them after we finish all the topics which were present in the crash course. Okay, you discuss with your friends and you can discuss within yourself also, and you can send me in the chat box that which topics you need to revise again. Okay. Yeah, okay, very good. So now let's start with our session. Okay, today we are going to talk about alcohol, phenol and ether. In this alcohol, phenol and ether, we are going to start from first of all alcohol, then phenol and then ether. Okay, so here, yeah. First of all, let's talk about the preparation of alcohol. So with the help of which methods we can prepare alcohol? So alcohol we can prepare by using these certain reactions. Okay, what are those reactions? By using acid catalyzed hydration. Here alkanes, okay, alkanes reacts with H2O in presence of acid. Okay, this is what alkenes actually. So here will be what alkenes. So here alkene reacts with water in presence of what? Acid as a catalyst. This is a Markovnikov's addition, where what happens is the negative part of a given substrate or given what we are going to add H2O, H plus and OH minus it is having. The negative part goes to the carbon atom which contains less number of hydrogen. This contains less number of hydrogen. So that is what our Markovnikov's rule. So here OH minus will go to that carbon atom. Here this carbon contains one hydrogen, this carbon contains two hydrogen. So that's why here the negative part is going to attach. So this is a very, very important reaction. Please remember this. Next, hydroboration oxidation. This is again very, very important reaction. Diborane molecule reacts with the given alkene to give us a trialkyl boride, which undergoes into hydrolysis with respect to H2O2 and OH minus ion. And here what happens is that peroxide is present, and that's why anti-Markovnikov addition takes place and we get the alcohol like this way. So here we are getting secondary alcohol, but here we are getting the primary alcohol. Very, very important reaction. This is again very, very important reaction in hydrocarbons. We have already learned these reactions. Okay. Hydrocarbon chemical properties of alkene. We have already learned these reactions, right? Next, reduction of aldehydes and ketones. So this reaction also we have learned in aldehydes and ketone. So in aldehydes and ketone, when we need to reduce them, if we use a hydrogen with palladium catalyst, we get primary alcohol, but there is a ketone, then we get what? Secondary alcohol, right? Next, this reaction also we have studied in acids, that acid when react with LiLH4, H2O, when it undergoes into reduction, directly COOH group gets converted into CH2OH. So we get the alkane, we get the alcohol, right? Any doubts so far? Yeah, so let's move on to the next. So from Grignard reagent. So when ketone reacts with the Grignard reagent, there is a formation of the Grignard complex, and later on we get what? Alcohol. But here there were two alkyl group. Now there are three alkyl group and OH present. Okay, so we get a tertiary alcohol when ketone reacts with what? When ketone reacts with what? Our Grignard reagent. When ketone undergoes into reduction, we get secondary alcohol. See the difference. Okay, when ketone reacts with Grignard reagent, we get tertiary alcohol. When ketone undergoes into reduction with NaBH4, we get secondary alcohol. Any doubts about this? Yeah, let's move on to the next. So what are the physical properties of alcohol? So alcohol is what? Colorless with characteristic smell. Alcohol, you know, the smell means you must be heard of the smell, or you must be knowing that alcohol is what have characteristic smell. Okay, they are soluble in water due to hydrogen bonding. So they are very, very soluble in water because hydrogen bonding takes place. These are partially soluble in organic solvents. Okay, they are liquid in up to 12 carbon. Okay, 12 carbon atom chain, they are liquid. Melting point and boiling point of these alcohols are directly proportional to their molecular masses, and it is inversely related to number of branches. So if number of branches are more, what will happen? The melting point and boiling point will be less, right? Why we have seen this? Because the structure becomes smaller and smaller, right? If more branching is there, the structure become more circular, and the melting point and boiling point for this will be what? Less. Next, boiling point of alcohols are higher than the corresponding ethers due to hydrogen bonding. So for alcohols, the boiling point is more over what? Ether. Please remember this, right? Yeah. Next, chemical properties of alcohol. So when we talk about the chemical properties of alcohol, there are very simple reactions actually. When alcohol reacts with the metal, so what does they form? There will be formation of this type of molecule, and H2 get liberated during this given process. So this is what sodium, potassium, or chlorine can be a M. Okay. If acid reacts with what? Our alcohol, there will be formation of ester. We know this reaction, ester formation, right? Again, if acetyl chloride reacts with the alcohol, there is a formation of ester. So these are very, very important reaction. Okay, esterification reactions are these, right? Next, alcohol when reacts with the Grignard reagent, when Grignard reagent reacts with our alcohol molecule, there will be formation of what? Alkanes. Okay, R-H means what? Hydrocarbons ka formation hota hai. Next, this is very, very important reaction. Alcohol when reacts with HCl in presence of Zn, anhydrous ZnCl2. So here what happens is there is a formation of what? Alkyl halide. Okay. Yesterday also we have seen this reaction when as alcohol react with HCl, there is a formation of haloalkanes, right? If this type of alcohol reacts with in presence of concentrated H2SO4, there will be formation of alkene. This reaction also we have seen in the alkene chapter. Okay, hydrocarbon. Now here, when we do the oxidation of alcohol, we get aldehyde. But when we do the oxidation of aldehyde, we get its respective acid. Right? So this is all about the chemical properties of alcohol, physical properties of alcohol, as well as how you are going to prepare the given alcohols. Right? Any doubt regarding this? Yeah. Now let's talk about the previous year questions, as well as let's talk about the certain questions we are going to solve regarding to this chapter. Yeah. Okay, Gauri Lakshmi. About this topic, that is alcohol. Okay. Yes. First of all, when vapors of secondary alcohol is passed over heated copper, yeah, at 573 Kelvin, the product form is. So when vapor of secondary alcohol is passed over heated copper, okay, so ये reaction हम लोगों को दिया हुआ है. What will be the product form during this given reaction? So we need to find out the product here. Okay, here you can see in this question what is asked. We need to find out the product. So here I have written the secondary alcohol. Okay, secondary alcohol was given. So which alcohol we need to consider, that was not given. So I have just considered R and R. Okay, so overall two substituents are present which are attached to this carbon atom, and OH is attached to this secondary alcohol. When it undergoes into heating, okay, with copper metal, what does it forms? It forms ketone. Okay, what does it forms? It forms a ketone. This is an oxidation reaction, right? This is an oxidation reaction. There is what? A formation of ketone. And out in this, very, very important and simple reaction. Okay. During ketone formation, we have seen this reaction actually. Next, a compound A on treatment with sodium. So यहाँ पे क्या दिया हुआ है? A compound A on treatment with sodium gives compound B, and with PCl5 gives compound C. B and C react together to give diethyl ether. What is the A, B, and C, and in the order? Okay, whatever the order is given to us, what will be those A, B, and C, that we need to find out. So A is the compound. So I have taken one of the option here, and I have done the reactions. Okay, so I have taken the option C. Yeah, Ayushi. Okay, I'm going to talk about this. Okay, so here what is happening? Alcohol is there, whose reaction with sodium we get this type of molecule. Okay, but when alcohol reacts with PCl5, we get the halide, right? So this is B compound, this is B compound, and this is C compound. When they both combine, there is a formation of what? Ether. What is that ether? Diethyl ether. And this is what? Our answer. ठीक है, so कौन से होंगे हमारे पास? A, B और C. तो A, B और C में हमारा ऑप्शन है C. ठीक ठीक है, क्योंकि यहाँ पे देखो C2H6 है, ठीक है, बी हम लोगों को C2H6 है, लेकिन वो बी नहीं है ना, हमारा बी ये है, ठीक है, हमारा सी क्या है, ये है, ठीक है, C2H5Cl, C2H5Cl यहाँ पे अलग दिया होता है, इसलिए हमारा ऑप्शन क्या है, सी इज द करेक्ट आंसर। आयुष यू आर राइट, ऑप्शन सी इज द करेक्ट आंसर। या next, how many isomers of C5H11OH will be primary alcohols? Yeah, we need to find out how many isomers of this given molecule will be the primary alcohol, 5, 4, 3 or 2. So what do you think, how many isomers of this given alcohol will be primary alcohols? Yeah, any answers? Okay, C5H11OH, try to draw the isomers of this molecule. Okay, so here you can see one isomer, another isomer, third isomer and fourth isomer I have drawn. Okay, so यहाँ पे आप देख सकते हो, this is what primary alcohol, right? This is again primary alcohol, this is again primary alcohol, and this is again primary alcohol, right? So there are total 4 primary alcohols are possible for this given molecule, that is C5H11OH, right? This is what, pentanol. Okay, right? Any doubts in this? Very simple. If you know how to draw the molecules, you will be able to find out this option. Okay, you will be able to find out this given question. Answer you will be able to find out. Okay. Yeah. Next, which of the following reaction can be used for the preparation of alkyl halides? So there are 4 reactions given, and with the help of which reaction we can be able to prepare what alkyl halides. So पहला reaction दिया हुआ है अनहाइड्राइज्ड ZnCl2 के साथ, दूसरा reaction दिया हुआ है HCl है, कुछ भी प्रेजेंट नहीं है, यहाँ पे टर्शरी अल्कोहल है, कुछ भी प्रेजेंट नहीं है, यहाँ पे भी हमारा सेकेंडरी अल्कोहल है और HCl है एंड ZnCl2 प्रेजेंट। So whether this only, this only, this only or this only, that is the answer. So which option will be correct? So now let's talk about the first reaction. Here what is happening in the first reaction, that CH3CH2OH, okay, it reacts with the HCl in presence of ZnCl2. It reacts with HCl in presence of ZnCl2. So what does it forms? It forms the compound like this way. Okay, it forms the compounds like this way. So here I have denoted R, but what is R? R is the ethyl group, right? So after that, what happens is this molecule, okay, the ZnCl2 and O, they break together. Okay, there is a breaking of this and there is a formation of carbocation. There is a formation of what? Carbocation. And this carbocation form is intermediate in this SN1 mechanism. The carbocation form during this reaction is what? Our intermediate, because this reaction is what? SN1 type of reaction. It is what? SN1 type of reaction. Yesterday only we have learned about SN2 and SN1. Okay, so here what happens is that in the first molecule, the carbocation form will be what? Ethyl carbocation, that is CH3, CH2 plus, which is a primary carbocation, which is what? Primary carbocation. In the second also, we get the primary carbocation. In the third reaction, what we are going to get? We are going to get a tertiary carbocation. Okay, we are going to get a tertiary carbocation like this way. Okay, in the fourth, now what is happening? There is a secondary carbocation we are going to get. So this is a secondary carbocation. Okay, so if this reaction, right? If this reaction is SN1, then we know that tertiary is more reactive than secondary, is more reactive than primary. For primary, the reaction will take place very, very slow. Okay, so here, due to the presence of ZnCl2, which acts as a Lewis acid and interact with alcohol, okay, and it forms a very good what? Carbocation. But in absence of ZnCl2, formation of primary carbocation is very, very, very difficult. Means what? There is no formation of carbocation when there is no ZnCl2. So here you can see there is no ZnCl2 present. Okay, यहाँ पे ZnCl2 present ही नहीं है, इसलिए इससे primary alcohol form करना जो होगा, that will be very, very difficult process. And that's why this process cannot take place. This can take place because nitrous ZnCl2 present, it is a Lewis acid. यहाँ पे क्या है? हमारा carbocation ही good है. That's why we don't need any kind of catalyst here. So this can happen. Here, even here secondary carbocation is going to form, but what is present? Catalyst is present, and which is going to accelerate a given reaction, and that's why this is also possible. So which options means 1, 2, 3, 4, which are possible? 1, 3, and 4. So which option is correct? Option A, 1, 3, and 4 only are going to prepare the alkyl halides, right? Any doubts in this? Do you understand this? Yes? Yeah, let's move on to the next problem. Yeah, very good, Gauri Lakshmi. Okay, yeah. Number of isomeric alcohols of molecular formula C6H14O, which gives positive iodoform test is. So, you know which compounds give iodoform test? Yeah, we have talked about this. Which compounds give iodoform test? Yes? Ketone, yeah. Okay, so why does ketone give? So they contain CH3CO group. Okay, the compounds which contain CH3CO group. Very good. Okay, CH3CO group. The compounds which contain CH3CO group, they give iodoform test. Okay, so C6H14O, when I write that molecule in terms of these two isomers, then it will be able to give us what? Iodoform test. Then it will be able to give us what? Iodoform test. So that's why how many isomers are possible for this C6H14O? So 4 isomers are possible. Okay, 4 isomers are possible. I have written here them. All the 4 options. Okay, यहाँ पे ये 2, 3 और 4. ठीक है, ये side same है. ठीक है, this side is same. Here totally linear. One substituent at the first side near to the OH. Then it is going farther. It is going further. Okay, like that way we have just changed the structure, and that's why there are 4 isomers possible, right? Any doubt? So this is very simple problem. Next, in the following sequence of the reaction, what will be the product C? So here we need to find out the product C: acetone, methane, acetaldehyde, and ethyl alcohol. So first of all, there is a methyl bromide which reacts with the KCl. So what will happen? Substitution is going to take place. Br is going to remove, and on the place of bromine, what is going to happen? Cyanide is going to come. Okay, which undergoes into hydrolysis. You know, when cyanide undergo into hydrolysis, what happens? There is a production of acid. When acid undergoes into reduction, what happens? COH will get converted into CH2OH, that is alcohol. So what is going to form here? Ethyl alcohol is going to form, that is option D. Any doubts? Simple reaction, right? Yeah. Next problem. When the glycerol is treated with excess of HI, it produces. So glycerol ka structure pehle bana lo. What is the structure of glycerol? So this is the structure of glycerol. When it reacts with HI, excess of HI, what happens is there is a production of 2-iodopropane. Okay, there is a production of 2-iodopropane. So how does it forms? So when glycerol reacts with HI, there is a production of, यहाँ पे I लग गया OH की जगह, यहाँ पे OH की जगह I लग गया, यहाँ पे भी OH चला जाएगा और I आ जाएगा. So there are triiodo. Okay, out of this triiodo, I2 molecule is removed or eliminated, and there is a formation of double bond. After the formation of double bond, you know the solution is in excess amount of HI. So what happens is, again this double bond undergoes into reaction, and it gives hydrogen to this side and iodine to this side. Okay, again H2 molecule, again I2 molecule is going to be removed from a given molecule. Okay, उसके बाद थोड़े देर बाद क्या होता है? वहीं पे reaction. This is a continuous reaction in which as soon as the next compound forms, the next our HI molecule adds, or I2 molecule gets eliminated up till which stage? So यहाँ पे again double bond has been formed. Okay, now again what will happen? H and I are going to added. So यहाँ पे you can see here H has added. So CH3, CH, CH3. So this compound is actually CH3, CH and CH3. So here is I. So what is this compound? 2-iodopropane, right? This is what? 2-iodopropane. So very good question actually. It's a very good question. 2-iodopropane. You will just read the question now. The glycerol is treated with excess HI, it will produce. So we'll think about this reaction. And what you are going to do is na CH2OH, CHOH and CH2OH. पहले तो glycerol का formula याद रखो. ठीक है? बाद में उसमें आप अगर HI डालोगे, then you will think that one of the HI will get what? Replaced by the I. But here excess was given. So what? Again you will think that all the OH will get converted into I. But what will happen about the H na? HI ka H ka kya hoga? So you will give this answer. Glycerol triiodide. And you will be very good and confident that I know the answer. glycerol triiodide is going to form. But that is not the case here. See what is happening here. Here, first of all, one molecule is going to add. Okay, all the molecules have been added. After that, there will be removal of I2. After removing I2, again add HI. Again remove I2. Again add HI. So these two steps are very, very important. Then only we get the final product. That's why the product will be 2-iodopropane, not this one. Are you getting it? ये trick करने वाला question था. Next problem. Consider the following reaction. Ethanol, when reacts with PBr3, it gives X molecule, which undergoes into alcoholic KOH and gives Z molecule. What is the product Z? So let's try to solve this problem. So यहाँ पे I have written ethanol. Okay, ethanol का यहाँ पे structure दिया नहीं था, लेकिन we know the structure, right? Add करो PBr3, what will happen? The substitution reaction is going to take place. OH will get replaced by Br. Alcoholic KOH डालोगे alcohol bromine में, तो क्या होगा? Alkene form हो जाएगा. Alkene when reacts with acid, what does form? It forms this type of compound. Okay, HSO4 यहाँ पे लग गया, एक H यहाँ पे लगेगा. Okay, H and HSO4. So one hydrogen is added here and HSO4 is added here across the double bond. Okay, so this type of molecule we get which undergoes into what? Heating. Second कह दिया H2 और heat करने के बाद आपको क्या मिला? फिर से ethanol ही मिला. So our answer is what? C. C. Reaction देखो क्या हुआ? इथेनॉल से स्टार्ट किया और इथेनॉल ही आप लोगों को मिला है, राइट? जहां से शुरू किए वहीं पे गए. चलो नेक्स्ट प्रॉब्लम. या नेक्स्ट टॉपिक दैट इज व्हाट? फिनॉल. So phenol, first of all, let's talk about the preparation method. So phenol we can prepare by using 3 to 4 method. First from chlorobenzene, then benzene, then aniline and cumene. Okay, when chlorobenzene reacts with the base NaOH, they at around certain temperature and around certain pressure, in presence of acid, we get phenol. You know the structure of phenol, right? OH. This is our phenol. Again, we can produce phenol when benzene reacts with oleum. Okay, and we get phenol. Okay, this is another method of preparation of phenol. Next, aniline. You know aniline, structure of aniline. Do you know the structure of aniline? Yeah. Here is what? NH2. When this aniline reacts with NO2, diazonium salt get formed. Yesterday only we have seen which is the diazonium salt. Okay, which is a diazonium salt, N2 plus and Cl minus. So this is our diazonium salt, which on hydrolysis gives us water. So यहाँ पे से ये निकल जाता है और हमको क्या मिलता है? Phenol. Very good. Next, cumene when reacts with undergoes into oxidation, we get phenol. Right? Any doubts about this preparation methods? Right. So let's move on to the physical properties of phenol. So phenol are colorless crystalline solid or liquid. They have characteristic order. Okay, they have very good order. Okay, due to the hydrogen bonding present in the phenol, they have higher boiling point and more solubility compared to the arene compounds, which contain approximately same molecular mass. So when we talk about the aryl compounds, which are having only benzene in them, and if we talk about the phenol compounds, which are having OH in them, okay, so the boiling point and hydrogen bonding is more for phenol as compared to the aryl system. Okay, arene system. Next, chemical properties of phenol. So how you are going to see which reactions are given by the phenol. So there are total 1, 2, 3, 4, 5, 6 reactions, which are very, very important reactions from the point of view of our exam. So phenol when reacts with dilute HNO3 at around certain temperature, we get what? Para and ortho product. But out of this para and ortho, major is what? Ortho product. Ortho is major as compared to para. If suppose what happens is we have a nitrating mixture that is concentrated HNO3 and concentrated H2SO4. So the reaction never stop at the ortho position. All the 3 NO2 molecule gets attached to a given phenol. And this is very, very important reaction because here picric acid is formed. And this is what? Very, 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 very strong acid. Okay. Next, Br2 and CS2, when this reacts with the given phenol, this is what? Electrophilic substitution reaction. So here again para and ortho product form, but here what? Para is more. Okay, para we get in the major quantity. देखो यहाँ पे हमको ortho measure में मिला, यहाँ पे हमको para measure में मिला, right? If we have the excess of Br2, that is aqueous, again similarly nitrating mixture, there is a formation of tribromophenol. Okay, there is a formation of tribromophenol. When base reacts with the our phenol, there is a formation of salt of phenol, which undergoes and react with CO2 to form acid. and this reaction we already seen, which is known as a Kolb's reaction. Okay, which is known as a Kolb's reaction. When it reacts with the CHCl3 and NaOH, what is the name of this reaction? Yeah, again in this reaction, which is what? Riemann-Tiemann reaction, right? It is what? Riemann भी बोल सकते हो आप, Riemann-Tiemann reaction, in which there is a formation of CHO, that is aldehyde. In the preparation of aldehyde, we have seen this Riemann-Tiemann reaction, right? Very, very important. Okay, so now let's try to solve certain problems about our phenol molecule. Okay, so the structure of intermediate A in the following reaction is, so you can see there are 1, 2, 3, 4 structures and we have given the reaction. यहाँ पे O2 का reaction हो रहा है, उसके बाद उसका hydrolysis हो रहा है, then we are getting these two compounds and we have to determine which is intermediate A and what is going to form as an intermediate. So पहला होगा, दूसरा होगा, तीसरा होगा, चौथा होगा. So यहाँ पे हमको हुआ है बेंजीन, बेंजीन के ऊपर लगा हुआ है आइसोप्रोपिल ग्रुप. ठीक है, so देखो, this is what? Cumin, okay, which reacts with O2 and what does forms? It forms the molecule like this way. Okay, Gauri Lakshmi B, yeah, we will discuss this. Okay, so here you can see cumin on oxidation. What does it forms? It forms one acid. So CH के बजाय यहाँ पे आ गया COOH. ठीक है, ये CH3 वैसे के वैसे, ये CH3 वैसे के वैसे. ठीक है, after this cumin hydroperoxide, what happens is it undergoes into hydrolysis and we get this type of compound. ठीक है, तो ये बहुत ही अच्छी रिएक्शन थी एक्चुअली, और यहाँ पे हमको आंसर मिल रहा है बी, क्योंकि ये हो गया हमारा इंटरमीडिएट ए. Okay, that's why here our answer will be what? B. So here we are getting option intermediate A like this way, cumin hydroperoxide. Cumin hydroperoxide, right? Any doubts in this? Okay, let's move on to the next. In this reaction, what is this reaction? You know, yes, this reaction is what? Riemann-Tiemann reaction, right? Phenol when reacts with CHCl3 in presence of base, there is a formation of CHO and salt. This reaction is called Riemann-Tiemann reaction. The electrophile involved here is, you know what is the electrophile involved here? Dichloromethyl cation, formyl cation, dichlorocarbene and dichloromethyl anion. So here which type of molecule intermediate forms is? Alpha elimination होता है CCl3 में से. Okay, CHCl3 में से हमारा हाइड्रोजन चला जाता है, then there is a formation of CCl3 minus and H plus. Okay, and this CCl3 minus forms the given from the given dichlorocarbene molecule, and this dichlorocarbene molecule attacks on the given phenol, right? So this is what dichlorocarbene intermediate is formed in during a Riemann-Tiemann reaction. Found to produced by reacting Y with NaOH and yields a yellow precipitate with characteristic smell. What is A and what is Y? Okay, so we need to find out A and Y. So यहाँ पे you can see haloform reaction is shown by the compounds having this type of compound as well as this type of group. So उनको क्या होता है, हम लोगों ने अभी देखा आइडोफॉर्म टेस्ट में. ठीक है, क्या होता है, जो हमारे CH3CO ग्रुप कंटेन करते हैं as well as CH3COH ग्रुप कंटेन करते हैं. These are what? इनॉल फॉर्म. ओके, कीटोइनल फॉर्म में है यहाँ पे. तो ये जब मॉलिक्यूल में प्रेजेंट होते हैं ना CH3CO और COH, देन दे शो द आइडोफॉर्म टेस्ट. सो यहाँ पे वही हो रहा है, सोडियम ऑक्साइड NaOH और I2, इनका जो फॉर्मूला है वो फॉर्म होने के बाद ये फॉर्म हो रहा है. ठीक है, इनका जब रिएक्शन हो रहा है, व्हाट वी आर गेटिंग इज सॉल्ट एंड वी आर गेटिंग द येलो पीपीटी ऑफ CHI3. We are getting the yellow PPT due to what? CHI3. So what is our answer here? Option D. समझ में आया? एक कंपाउंड हम लोगों ने लिया था C8H10O. ओके, उसका रिएक्शन किया NaOI से, जो कहां से प्रोड्यूस्ड हुआ है? रिएक्टिंग Y विथ NaOH. सो Y को मतलब Y क्या है? हमारा I2 है. उसकी रिएक्शन जब मैंने NaOH के साथ की तो मुझे क्या मिला? NaOI. So this is again good question, right? Recently asked. Okay, yeah. Next, identify the major product PQR in the following sequence of reaction. So here we need to find out P, Q and R. So here you can see P, Q and R are given. Okay, P, Q and R are given. So R is this one. Okay, or this given first option ये R है. ये हमारा ऑप्शन भी है नीचे का. ठीक है, यहाँ पे भी ये R है. ओके, ये R है और ये R है. राइट? Very good. So now identify the major product PQR in the following reaction sequence. So यहाँ पे हमारा बेंजीन है, उसकी रिएक्शन हो रही है एसिटिल हमारा एसिड हेलाइड से, ठीक है, नॉट एसिड हेलाइड, सॉरी, हाइड्रोजन हेलाइड, सॉरी अल्किल हेलाइड, वेरी वेरी सॉरी, alkyl halide. Okay, so our benzene is reacting with alkyl halide in presence of anhydrous AlCl3. So which type of reaction is this? FC alkylation. Okay, this reaction is FC alkylation. So what is the mechanism of this reaction? You can see there will be formation of, first of all, carbocation from this given halide. Okay, उसका कार्बोकटायन फॉर्म होगा, वो प्राइमरी कार्बोकटायन था, तो प्राइमरी कार्बोकटायन इतना स्टेबल नहीं होता है, इसलिए यहाँ पे हाइड्रोजन शिफ्ट हुई एंड देयर विल बी फॉर्मेशन ऑफ सेकेंडरी कार्बोकटायन, ठीक है, right? Then this undergoes into reaction with electrophilic substitution reaction with the benzene molecule, and there is a formation of this type of molecule which is a cumene, right? CH3 CH3, this is what cumene, which undergoes into oxidation to form again this molecule. अभी हम लोगों ने ये रिएक्शन देखा था, लेकिन देखो ये अलग प्रकार से पूछा गया है, इस तरह हम लोगों ने देखा था, राइट? फिर क्यूमेन हाइड्रोपेरोक्साइड का हम लोगों ने अगर हाइड्रोलिसिस किया, देन वी गेट फेनॉल अगेन एंड वी गेट एसीटोन. सो दिस इज द प्रिपरेशन ऑफ फेनॉल रिएक्शन. ओके, वी गेट फेनॉल एसीटोन एज आर प्रोडक्ट एंड पी प्रोडक्ट कौन सा है हमारा? क्यूमीन. तो कौन सा ऑप्शन हो गया देखिए आप, यू कैन सी दिस इज नॉट करेक्ट बिकॉज यहाँ पे क्या होती है, रीअरेंजमेंट होती है कार्बोकटाइन की, इसलिए सेकेंडरी कार्बोकटाइन फॉर्म होगा. दैट्स व्हाई सच टाइप ऑफ विल नॉट फॉर्म. ओके, ये होगा या फिर ये होगा, ठीक है. दूसरा क्या है, क्यू हमारा मिल रहा है, ये CHO कहाँ से आएगा? CHO नहीं आया है, यहाँ पे OH आएगा, तो OH एंड OH. नेक्स्ट यहाँ पे अल्कोहल दिया हुआ है, लेकिन वी गेट एसीटोन. दैट्स व्हाई ऑप्शन सी इज द करेक्ट आंसर हियर, राइट? एनी डाउट रिगार्डिंग दिस? वेरी गुड एग्जांपल एंड वेरी गुड प्रॉब्लम. हम लोगों ने इस तरफ की रिएक्शन जो है P से Q की तरफ जाने की, वो ऑलरेडी देखी थी, ठीक है. P से Q तरफ जाने की रिएक्शन हम लोगों ने ऑलरेडी देखी हुई थी. ओके, समझ में आ रहा है सबको? एनी डाउट्स? Okay, next reaction. Which of the following is most acidic compound? So which will be the most acidic compound here? Which contains electron withdrawing group? C. Yeah, very good. Very good. C will be the most acidic. Very good. Okay, which shows minus I and minus R effect. So compound 3 will be most acidic. Which of the following reagent would distinguish cis-cyclopentane 1,2-diol from the trans isomer? So this is again a very good question. We need to find out the reagent among acetone, ozone, MnO2 and aluminum isopropoxide, which we can distinguish from cis-cyclopentane from its trans isomer. Okay, cis और trans में से हम distinguish कर पाए, ऐसा कौन सा reagent हम लोगों को मदद करेगा, ठीक है? It will help us. So you can see cis-cyclopentane 1,2-diol. This is our diol. When this reacts with acetone, what does it forms? It forms cyclic acetal. Okay, but such a type of cyclic acetal is not possible in terms of trans isomer. ठीक है, ट्रांस आइसोमर कैसा होगा? एक ऊपर होगा और एक नीचे होगा, ये OH और ये OH, ठीक है. इसमें आप ऐसे एसिटल नहीं फॉर्म कर सकते, राइट? यू कैन नॉट एबल टू फॉर्म द एसिटल विद द ट्रांस आइसोमर फॉर अ गिवन of a given compound, and that's why this is what not possible. So with the help of acetone we can distinguish. Okay, acetone के साथ हमारा ट्रांस आइसोमर कभी भी साइक्लिक एसिटल कीटल नहीं फॉर्म कर सकता, ठीक है. that's why our answer will be acetone. Any doubts everyone? You know how to form the acetal या फिर कीटल. यहाँ पे कीटल फॉर्म हुआ, देखो कार्बन ऑक्सीजन और कार्बन, ये जो फॉर्म हुआ है इसको हम बोलते हैं कीटोल. क्यों कीटल बोल रहे हैं? क्योंकि ये कीटोन से फॉर्म हुआ है, ठीक है. नेक्स्ट, रिएक्शन ऑफ फेनॉल विद क्लोरोफॉर्म इन प्रेजेंस ऑफ डाइल्यूट सोडियम हाइड्रोक्साइड फाइनली इंट्रोड्यूसेस व्हिच वन ऑफ द फॉलोइंग फंक्शनल ग्रुप? ओके, हम लोगों को रिएक्शन करना है फेनॉल और क्लोरोफॉर्म का, ठीक है, डाइल्यूट सोडियम हाइड्रोक्साइड. सो रिएक्शन इज अगेन सेम. व्हिच इज दिस रिएक्शन? एवरीवन टेल मी. फेनॉल when reacts with what? Chloroform, CHCl3 plus NaOH, right? Which is this reaction everyone? Finally introduces which one of the following functional group? और कौन सा functional group वो introduce करते compound में? Yes, you have to give me the answer. OH is as it is. There will be production of, yes Sushant, very good. This is what? Reamer-Tiemann reaction. Reamer-Tiemann reaction. Okay, this is what Riemann-Tiemann reaction. Here what happens? Dichlorocarbene is our what? Is our what? Active species, which is going to attack on our phenol. See here what is happening. O minus. ओके इस तरह से रिएक्शन हो रहा है हमारा कार्बन के साथ. और यहाँ पे फिर से आ गया माइनस माइनस. नाउ H2 इज गोइंग टू ऐड. ओके OH माइनस H प्लस यहाँ पे लग गया. ठीक है. Again what will going to happen, hydrolysis will takes place and this CHCl2 will go and there will be formation of CHO group. So here which functional group is introduced in Riemann-Tiemann reaction? So CHO functional group is produced. देखो रिएक्शन आपको पता है, उन्होंने अलग तरह से पूछ लिया. ठीक है, आपको रिएक्शन पता है, आपको प्रोडक्ट भी पता है. यहाँ पे क्या लगेगा? CHO. रीड करना है अच्छे से प्रॉब्लम. ओके, वेरी सिंपल. Next, which of the following is not the product of dehydration of this given molecule? अगर if suppose this molecule undergoes into dehydration, what is dehydration? Removal of H2O, right? Removal of H2O. So what is dehydration? Removal of H2O. So not, हम लोगों को इसमें से कौन सा प्रोडक्ट नहीं मिलेगा जब हम इस मॉलिक्यूल का डिहाइड्रेशन करेंगे तब. So this is very easy problem actually. Just pay attention here. So what will happen here? First of all, we need to do the dehydration. So in order to do the dehydration, we make OH as a very good leaving group. So in order to make the OH as a very good leaving group, I have added what? H plus to that. So what has happened here? H2O plus has been formed. So when this H2O plus will go, there will be formation of carbocation here, right? So this carbocation is what? Secondary carbocation. Okay, this carbocation is secondary carbocation. So there are three possibilities with the help of which this carbocation can be stabilized and there will be formation of double bond. Okay, and there will be formation of double bond. So what is that carbocation has been formed? So यहाँ पे है हमारा CH2 और ये है H और यहाँ पे है हमारा CH3. ठीक है, ये हमारा हो गया स्पीसीज. ठीक है, ये है हमारा कार्बोकेटाइन. ओके, तो यहाँ पे कौन कौन से हाइड्रोजन प्रेजेंट है? क्योंकि अभी तक सिर्फ हम लोगों ने H2O निकाला है, दैट इज OH गया है सिर्फ. ठीक है, यहाँ पे हाइड्रोजन कौन कौन से है? यहाँ पे एक नेबरिंग हाइड्रोजन है, यहाँ पे एक नेबरिंग हाइड्रोजन है. ठीक है, और यहाँ पे ये एक नेबरिंग हाइड्रोजन है. सो दीज थ्री कैन बी एबल टू स्टेबलाइज अ गिवन कार्बोकेटाइन. ओके, हाइड्रोजन शिफ्ट होके ये ऐसे आके हमको ये प्रोडक्ट मिल सकता है, ये यहाँ पे आके हमको ये प्रोडक्ट मिल सकता है, और ये यहाँ पे आके हमको ये प्रोडक्ट मिल सकता है, राइट? सो वी कैन गेट दीज थ्री प्रोडक्ट्स. तो ये कौन कौन से ऑप्शंस में है? देखिए, ये क्या है हमारा ए ऑप्शन. ठीक है, ये क्या है हमारा? दिस इज अगेन ए ऑप्शन ना. तो यहाँ पे यहाँ अलग लिखना चाहिए. ठीक है, सॉरी फॉर दिस. या सो यहाँ पे हम लोग यहाँ लिखेंगे, राइट? नेक्स्ट, ये कौन सा ऑप्शन है? फिर इसे यहाँ पे करोगे तो डी ऑप्शन हो जाएगा. ये दिस इज द डी ऑप्शन, दिस इज द ए ऑप्शन, दिस इज द सी ऑप्शन. So which is not applicable here? B option is not applicable because यहाँ पे नहीं आ सकता. यहाँ का हाइड्रोजन आपको फिर निकालना पड़ेगा. ठीक है, वहां का हाइड्रोजन क्यों निकलेगा ना, क्योंकि यहाँ पे ऑलरेडी 3 हाइड्रोजन है. So this type of product is not possible. These 3 are possible. Okay. Next problem, among the following sets of reactants, which one produces anisole? You know anisole, benzene ring attached to OCH3. Right? Benzene ring attached to OCH3. So which will give us the anisole? So here when phenol reacts with our NaOH in presence of CH3I, we get anisole. Okay, we get anisole. So that is what? Option B. Remember this reaction. Okay? हम लोगों ने देखा है ये reaction. ठीक है ना? Next, which of the following will not be soluble in sodium hydrogen carbonate? So triphenol नहीं होगा, benzoic acid नहीं होगा, orthonitrophenol और benzene sulfonic acid. So orthonitrophenol will not be soluble in sodium hydrogen carbonate. Why? Because the intramolecular hydrogen bonding of hydrogen on OH is strongly bounded, and so it cannot behave as an acid and cannot react with sodium bicarbonate. Okay, it is not going to react with the sodium bicarbonate. That's why C is the correct answer. Orthonitrophenol. So sometimes what will happen is now, instead of giving you names, they will give you the structure. Okay, so this is what orthonitrophenol. Next, phenol is distilled with zinc dust followed by Friedel-Crafts alkylation with propyl chloride in the presence of AlCl3, which gives compound B. Right? B is oxidized in presence of air to form the compound C. The structural formula of C is. Yeah, this is again very good question. let's try to solve this question. तो यहाँ पे फिनॉल का रिएक्शन हो रहा है प्रेजेंस ऑफ हीट. तो क्या होगा, फिनॉल का जब जिंक डस्ट के साथ रिएक्शन होता है तो वो OH चला जाता है और वी गेट द बेंजीन मॉलिक्यूल. Okay, we get the benzene molecule, and you know when it reacts with AlCl3 in presence of such a type of alkyl halide, there is a what regeneration, hydrogen shift occur in this given molecule, and there is a formation of cation, carbocation, which is what secondary carbocation. Okay, and that gets added onto a given benzene ring, and when it undergoes into what oxidation, there is a formation of hydroperoxide like this way, right? So product क्या है हमारा, C product है. C is our correct answer here. Okay, any doubts regarding this? Next, preparation of ether. So dehydration, when we talk about the preparation of ether, we need to start from dehydration of alcohol. So alcohol का जब dehydration होगा, उसमें से H2 molecule when we remove na, there is a formation of ether molecule like this way. So very simple preparation. Again, very important preparation is what Williamson synthesis. What is this Williamson synthesis? Is that when our halide reacts with the salt of oxide, okay, sodium oxide. So alkoxide के साथ जब हमारा halide react होता है तो R फॉर्म होता है और सोडियम halide एक तरह फॉर्म होता है. But the reactivity for this is what, primary or secondary or tertiary. So alkyl halide should be primary because secondary and tertiary alkyl halide will give elimination reaction rather than substitution. So हम लोग जो alkyl halide यहाँ पे use करने वाले हैं, it should be primary, then secondary, and then tertiary for the Williamson synthesis. Right? Next, very important is what physical properties of ether. So when we talk about physical properties, diethyl ether and ethyl methyl ether are gases. All other are colorless liquids with they have certain characteristic smell. Okay, they are sparingly soluble in water, but they are radially soluble in organic solvent. Solubility of ether in water is due to its hydrogen bonding between ether molecule and water molecule. Between ether molecule and water molecule, that's why it's have a good solubility. Boiling point of ether shows a gradual increase with increase in the molecular weight. Ethers have low boiling point than isomeric alcohol, as there is no association of hydrogen bonding between ether molecules. Okay, दो ईथर मॉलिक्यूल के बीच में हाइड्रोजन बॉन्डिंग प्रेजेंट नहीं है, इस कारण जो हमारा अल्कोहल है that have more boiling point as compared to the ether. The boiling points of ether are close to the boiling points of alkanes. These ethers are lighter than water, as well as lower ethers are highly volatile and inflammable. Okay, now let's talk about the chemical properties of ether. So chemical properties, when we talk about it, you can see the COO, RCOR. I will write here RCOR. Okay, this is what ketone, but we need to write down about ether. So for ether, what I'm going to do is I'm going to remove this carbon. So this is our ether molecule. So here for ether molecule, there will be cleavage of this RO bond. It is what COC bond. There will be cleavage of CO bond. Okay, so here you can see there is formation of RX and alcohol. Here there is formation of alkyl halide and water. Here there is a formation of phenol and halide. So reactivity of HX here is HI, HBr and HCl. Okay. Next, yesterday only we have seen this. Okay, why HI, why HBr, why HCl. Next, if this is our ether, it reacts with HI, there is a formation of this halide and alcohol. If excess of HI is present, now what is going to happen is that this CH3I will form. Again, this OH will get converted into CH3, CH2I. तो हमको अगर एक्सेस अमाउंट में होगा, अल्कोहल नहीं मिलेगा, सारा हेलाइड मिलेगा, एक साइड का एक हेलाइड और अदर साइड का एक हेलाइड. ठीक है. इफ सपोज दिस इज द मॉलिक्यूल, तो यहाँ पे क्या होगा, हम लोगों को टर्शरी वाला हेलाइड मिलेगा, क्योंकि ये रिएक्शन कौन सा है, SN1 वाला रिएक्शन है, इसलिए. ठीक है. नेक्स्ट, इलेक्ट्रोफिलिक सब्स्टिट्यूशन रिएक्शन जब होता है हमारे ईथर मॉलिक्यूल पे, तो आप देख सकते हो, अगर हमारा ईथर जो है, जो जिसको हम बोलेंगे एनिसोल, ठीक है, एक तरफ हमारी बेंजीन रिंग है, वो हमारा ऑक्सीजन है ईथर वाला, और यहाँ पे CH3 है, इसको हम कहते हैं एनिसोल. When it reacts with Br2, when it reacts with CH3Cl anhydrous AlCl3, that is, this is what FC alkylation, Fidelcraft alkylation, and when it reacts with the nitrating reagent. So we get para as a major product, para as a major product, and para as a major product. So when anisole is there, we always get para as a major product. Para as a major product. Very, very important. Now let's solve certain problems regarding this given what? ethers. So anisole on cleavage with HI gives. So cleavage हो रहा है anisole का स्ट्रक्चर अभी मैंने आप लोगों को ड्रॉ करके दिखाया था, right? This is our anisole OCH3. Yeah, tell me the answer. Option D. Right, very good, Sushant. Option D is the correct answer. How? So see here, what is going to happen? Cleavage of CO bond होगा, यहाँ पे एक फेनॉल मिलेगा और एक क्या मिलेगा हमको CH3I. ठीक है, क्योंकि रिएक्शन क्या है, SN2 रिएक्शन हो रही है. ठीक है, यहाँ पे एक SN2 है और यहाँ पे क्या है, SN1. ठीक है, राइट. नेक्स्ट, द मेजर प्रोडक्ट फॉर्म. तो यहाँ पे SN2 रिएक्शन हो रहा है, नॉट SN1. ओके, हियर SN2 रिएक्शन टेक्स प्लेस, CH3I we get and 1 OH. ठीक है, SN1 नहीं हो रहा, SN2 हो रहा है. नेक्स्ट, द मेजर प्रोडक्ट C and D form in the following reaction respectively are. So यहाँ पे excess HI है, heat कर रहे हैं. Can you tell me the answer? Here which reaction will take place? SN1 होगी या SN2 होगी? सिंपल है आंसर, बताइए चलो. सुशांत, लास्ट टाइम को बताया, वैसे ये भी बता सकते हो. SN1 होगा या SN2 होगा यहाँ पे? ABCD. एक्सेस HI है. एक्सेस HI होगा तो मैंने कहा है क्या होगा, अल्कोहल मिलेगा हमें या दोनों के दोनों आयोडाइड ही मिलेंगे? यस. सो व्हेन देयर इज अ एक्सेस ना, व्हाट विल हैपन, वी विल गेट बोथ द आयोडाइड्स. या reaction will be SN1 with respect to CH3CH, this tertiary group. Reaction will be SN2 with respect to this group. तो अगर एक ही HI होता ना तो पहले ये फॉर्म होगा, दैट इज SN1 रिएक्शन होगा. ठीक है, लेकिन यहाँ पे एक्सेस अमाउंट में दिया हुआ है तो ये अल्कोहल भी फिर से आयोडाइड में कन्वर्ट हो जाएगा. ठीक है, दैट्स व्हाई वी गेट बोथ आई. सो बोथ आई किसमें है, इसमें नहीं है, इसमें है, इसमें भी नहीं है, इसमें भी नहीं है. सो वी हैव आंसर, दैट इज ऑप्शन बी. Okay, everyone. Such type of reactions are asked, okay, from this section. Next, the compound that is most difficult to protonate is. So, which is most difficult to protonate? H2O, alcohol. ये हमारा है ether और ये हमारा phenol. कौन सा है difficult to protonate? What do you think? Yes, see here. Here in the molecule D, that is what? Our phenol molecule. ऐसा होता है फेनॉल मॉलिक्यूल, आपको पता है स्ट्रक्चर. दिस इज द स्ट्रक्चर ऑफ फेनॉल मॉलिक्यूल. यहाँ पे लोन पेयर प्रेजेंट है. सो लोन पेयर ऑफ इलेक्ट्रॉन प्रेजेंट ऑन दिस ऑक्सीजन आर इन्वॉल्व्ड इन डीलोकलाइजेशन, राइट? सो फेनॉल अमंग्स द गिवन कंपाउंड ड्यू टू लेस अवेलेबिलिटी ऑफ इलेक्ट्रॉन, व्हाट इज हैपनिंग टू इट इज व्हाट, इट इज मोस्ट डिफिकल्ट टू प्रोटोनेट. It is what? Most difficult to protonate. So that's why D is our correct answer. Okay, next. Heating of phenyl methyl ethers with HI produces. So phenyl methyl ether. Phenyl methyl ether निकालो. कैसे होगा phenyl methyl ether हमारा? या डालो आंसर लिखो. चलो ड्रॉ करो. मॉलिक्यूल फिनिल ग्रुप हो गया. ठीक है, अभी मिथिल ग्रुप लगा तो मतलब ये क्या हो गया हमारा? एनिसोल हो गया. इसका हम लोग अगर HI के साथ रिएक्शन करेंगे तो क्या फॉर्म होगा? अभी आप लोगों को बताया, एक फेनॉल फॉर्म होगा और एक क्या फॉर्म होगा? आयोडोमिथेन. ठीक है, तो एक अल्किल आयोडाइड फॉर्म होगा और एक क्या फॉर्म होगा? फेनॉल. ऑप्शन क्या है हमारा? बी. एनी डाउट? सेम प्रॉब्लम है लेकिन सिर्फ भाषा बदली है. ठीक है, नेक्स्ट. आइडेंटिफाई ए एंड प्रिडिक्ट द टाइप ऑफ रिएक्शन. यस, वी नीड टू आइडेंटिफाई द प्रोडक्ट here as well as which type of reaction is it. Okay, so see here OCH3Br NaNH2 की रिएक्शन हो रही है. A प्रोडक्ट हम लोगों को मिल रहा है. So when anisole is there na and it reacting with our NaNH2, so what happens there is what, it acts as a base. Okay, and it abstracts the proton from this side and there is a formation of benzene compound. Okay, there is a formation of benzene intermediate. So this type of benzene intermediate forms during this reaction. So this benzene intermediate can attack or can get attacked either by A side or by B side. So substitution can take place either this place or this place. Okay, so if this place, on this place if substitution happens na, it is what? Less stable. क्योंकि क्राउडिंग हो जाता है और यहाँ पे निगेटिव चार्ज है, वो किससे बैलेंस हो रहा है? किसी से भी बैलेंस वो हो नहीं रहा है. बट अगर we add NH2 from this side na, this negative charge get more stabilized and that's why this is what? More stable. So more stable due to negative charge is closer to the electron withdrawing group. Electron withdrawing group कौन सा है हमारा यहाँ पे? Yes, Also, incoming nucleophile gets attached on the same carbon on which bromine leaving group was present. तो यहाँ पे जहां पे ब्रोमीन गया ना, वहीं पे हमारा नेक्स्ट न्यूक्लियोफाइल ऐड हो रहा है, ठीक है। और यहाँ पे जो हमारा निगेटिव चार्ज था वो क्या होगा, विड्रॉइंग ग्रुप जो प्रेजेंट है हमारा, उसकी वजह से क्या हो गया, वो बैलेंस हो गया, ठीक है। सो दिस इज नॉट अ substitution reaction. Okay, this is not a syn substitution reaction. So which is this reaction? It is what? Only substitution reaction. It is what? Only substitution reaction. तो यहाँ पे ब्रोमीन चला गया और ब्रोमीन की जगह पे क्या आ गया बच्चों, NH2 आ गया. So that's why this is a substitution reaction. Elimination हुआ है क्या, ब्रोमीन का एलिमिनेशन हुआ, लेकिन NH2 का एडिशन हो गया ना, इसलिए सब्स्टिट्यूशन रिएक्शन हो गया. ब्रोमीन के जगह पे सिर्फ NH2 आ गया, ठीक है. तो ये सीन सब्स्टिट्यूशन नहीं है, दैट इज ओनली सब्स्टिट्यूशन रिएक्शन, राइट. सो ऑप्शन डी इज करेक्ट. नेक्स्ट, सी हियर दिस रिएक्शन, कैन यू टेल मी द आंसर. फेनॉल हमारा साइक्लोपेंटेनॉल है, उसकी रिएक्शन NOH के साथ हुई, हमको एक अल्कोक्साइड मिल गया. उसकी रिएक्शन जब हम मिथिल आयोडाइड से कर रहे हैं, वी गेट दिस टाइप ऑफ ईथर. विच टाइप ऑफ रिएक्शन इज इट? विलियमसन सिंथेसिस, अल्कोहल फॉर्मेशन रिएक्शन, डिहाइड्रेशन रिएक्शन. व्हाट डज इट? Option A. Okay, Sushant. So here answer is what? Option A. Very correct. Williamson ether synthesis reaction. Okay, this is a Williamson synthesis reaction in which alkoxide reacts with the alkyl halide to give the respective ether. Very good. Next, this is the reaction. Okay, what will be the product? Yeah, we need to tell the what will be the reaction. Williamson synthesis, Itard reaction, Gotterman-Koch reaction, Williamson synthesis. Yes, tell me. Yes. Again, this reaction is of which type? Alkoxide reacting with alkyl halide. So this is again what our Williamson synthesis. यहाँ पे देखिए रिएक्शन दिया हुआ है, ठीक है. अल्कोहल का रिएक्शन NaOH के साथ हो रहा है, अल्कोक्साइड मिल रहा है और आयोडाइड की रिएक्शन हो रही है. यहाँ पे रिएक्शन हमको ऑलरेडी सॉल्ट दिया हुआ है अल्कोक्साइड, उसकी रिएक्शन हमारी अल्किल हैलाइड के साथ हो रही है. So this is Williamson synthesis, not continuous etherification process. Okay, it is just a Williamson synthesis, one of the best method for the preparation of symmetrical as well as unsymmetrical ethers. In this method, alkyl halide is allowed to react with sodium alkoxide. यहाँ पे क्या हो रहा है, सोडियम अल्कोक्साइड के साथ हमारी अल्किल हैलाइड की रिएक्शन हो रही है. वेरी 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 इंपॉर्टेंट रिएक्शन. सुशांत, आपको ये आंसर आया था, ठीक है. ये भी रिएक्शन जो है वो भी विलियमसन सिंथेसिस है. Please understand about this. Okay, very very simple and very good for the previous answer also, right? Yeah. Now what will be the product here? Identify the Z in this given sequence. अल्किन दिया हुआ है, उसकी रिएक्शन HBr in presence of H2O2 हो रही है. क्या होता है, अल्किन की रिएक्शन अगर HB और H2O2 से हुई, दिस व्हाट एडिशन टाइप ऑफ रिएक्शन. अक्रॉस द डबल बॉन्ड H और Br ऐड होगा, लेकिन यहाँ पे H और Br, कहाँ पे Br जाएगा, H2O2 है, then it is going to follow anti-Markovnikov rule, right? It is going to follow anti-Markovnikov rule. So after doing anti-Markovnikov addition, there is what? C2H5ONa. तो ये क्या होगा, हमारा अल्कोक्साइड होगा. यहाँ पे क्या फॉर्म होगा, हमारा अल्किल हैलाइड फॉर्म होगा. जब अल्किल हैलाइड हमारा क्या करता है, इस तरह से हमारे अल्कोक्साइड के साथ रिएक्शन करता है, तो क्या फॉर्म होता है यहाँ पे, ROR, दैट इज ईथर फॉर्म होता है. ठीक है ना, बहुत ही सिंपल है. तो आप यहाँ पे देख सकते हो कि यहाँ पे पेरोक्साइड होने के कारण यहाँ पे एंटी मार्कोनिकॉफ एडिशन होगी. द नेगेटिव पार्ट दैट इज Br माइनस इज गोइंग टू गो टू दैट कार्बन एटम विच इज कंटेनिंग. वेरी गुड गौरी लक्ष्मी. या ऑप्शन ए विल बी द करेक्ट. सो यहाँ पे क्या होगा, ब्रोमीन विल गो टू दैट कार्बन विच इज हैविंग मोर नंबर ऑफ हाइड्रोजन एटम, मोर नंबर ऑफ हाइड्रोजन एटम. ठीक है, तो ये फॉर्म हो गया और ये ONa होगा, ये सिर्फ Na लिखा हुआ है, ONa होगा और हमको मिल जाएगा ये हमारा Z मॉलिक्यूल, दैट इज ऑप्शन ए. सिंपल. यस, एनी डाउट्स एवरीवन, एनी डाउट्स अबाउट दिस? नेक्स्ट, among the following ethers which one will produce methyl alcohol and treatment with hot concentrated HI? So हम लोगों को ईथर दिए हुए हैं, उनकी रिएक्शन करो कॉन्सेंट्रेटेड HI के साथ, हमको मिथिल अल्कोहल कौन सा मॉलिक्यूल देगा, 1, 2, 3 या 4, ABCD, which will give us the methyl alcohol? Yes, very simple problem. Can you answer me? मिथिल अल्कोहल चाहिए मुझे. Yes. Yeah, see here, option B will be the correct. Why? Because in this, what will happen? The reaction will proceed via SN1 mechanism. Okay, in this molecule, reaction is going to follow the SN1 mechanism. Here, SN1 mechanism, we get the what? Carbocation, which is highly stable. And then we get this type of iodide. अगर हमको ये iodide मिल गया, ठीक है, tertiary alkyl group is attached, then it forms alkyl iodide because of the stability of the tertiary carbocation. And after that, what will happen? Methanol is going to form. ठीक है, अगर ये हमको अच्छा देगा iodide, तो बचा हुआ molecule हमको क्या देगा? अल्कोहल देगा, क्योंकि यहाँ पे एक ही molecule ऐड हुआ है ना. ठीक है, समझ में आ रहा है सबको? We needed the methyl alcohol, right? Any doubts about this, everyone? समझ में आ गया सब लोगों को? Yeah, so thank you so much for joining in. That's it for today's lecture. If you have any doubts regarding alcohol, phenol, and ether, you can ask me. Okay? Thank you so much, Gauri Lakshmi, for attending the lecture. And please remember that if any topics you need to discuss again, you can send it to me. Okay? Send it in the chat box. I will try to explain it. Okay? We will talk about that topic. Because right now, all the organic chemistry we have finished. Now we need to finish such topics in which you are confused or you need more and more preparation for that. Okay? So such topic we can revise again. Or otherwise, I will take certain topics and I am going to revise them. Okay, Sushant, Gauri Lakshmi, you can tell me the topics or I will take the topics according to me and I will try to revise them. Okay? If you have any topics in your mind, you can send it to me. Okay, आज सोच लीजिए, कल आप मुझे बताएंगे तो भी चलेगा. ठीक है? Yeah, okay. Okay, Sushant. Okay, Gauri Lakshmi. Thank you. Thank you so much for joining in. So let's meet tomorrow for our session. Tomorrow topic is P block elements. Okay, group 13 and group 14.